So this is now what we are. Nevaeh left the meeting. Okay, so how many moles? So you see the word moles there. Go back. I lost my screen. Stop this and re-record. I'll try this again. All right. Okay, so you see how it says moles of CO2? That's a clue that you're going to do a conversion here. We're going to go from moles of CO2. We're looking for this. Are produced with 6 moles of CO. So here, what we have to realize is that we're changing compounds. Before now, when we were looking at how many grams per mole, how many liters are there in so many moles, we were staying in the same compound. For the first time, we're actually changing from one compound to another compound. And that means we're going to have to use the balanced chemical equation to do this. So we're going from here to there. In order to do that, we're going to use the coefficients. All right, so we've always said that the very first thing you want to do is put the number we're trying to convert over 1. So this 6 moles is going to go over 1, just like we always have. So 6 moles. We're talking about CO, so I'm going to take the time to actually write CO there. Don't get lazy with your units. Because especially with this one, because we're actually changing compounds. I was trying to get you guys to kind of start thinking about that in those terms later. But I don't know how much it really sunk in because I'm still yelling at people about doing that. So we have 6 moles of CO on the top. That means I want to put moles of CO on the bottom. Since we're using the coefficients, we have to use these numbers up front. Where we're going from is always going to be on the bottom. Where we're going to will be on top. So 2 moles of CO will be on the bottom. On the top is going to be 2 moles of CO2. So it's going to be 6 times 2 divided by 2. So we're going to end up with 6 again, 6 moles of CO2 this time. Notice we went from CO over to CO2. We changed compounds in this scenario. Okay, we can go on to the next one here. How many moles of O2 are needed? So we're looking for moles of O2. So this is where my question mark is going to be. How many moles of O2 are needed to produce 2 moles of CO2? We're starting off with 2 moles of CO2. This is my starting point. This time I'm going to go backwards. Once again, anytime you have that horizontal line, we're going to use those coefficients from the balanced equation. So this is our starting point. The 2 moles are our starting point. 2 moles of CO2 over 1. We have moles of CO2 on the top. We need to put moles of CO2 on the bottom. That coefficient is going to go on the bottom. We're being asked about oxygen, about O2. So So we're going to put moles of oxygen on the top. That coefficient in front of O2 is 1. So when we do the math here, the moles of CO2 cancel out, and I'm left over with moles of O2. We have 2 times 1 divided by 2. 1 mole of O2 is our final thing. Okay, so Alex asked the question, why did I work backwards? All right, so if I'm going to erase what I have here, and I'm going to start over a little bit. All right. So when we were doing this, we started off with 2 moles of CO2. All right, Alex, do you see what I'm saying right here? This is our starting point. Do you understand why that's our starting point? Okay, Alex is saying yes. I'm being asked about moles of oxygen. All right, that's how I know where my X is going to go, because the question is saying how many moles of oxygen. That's where I know to put the X. It does not matter if you go left or right in these equations. They can even be on the same side. It doesn't matter because it's all in the same equation. So since we started off with the CO2 here, that's why we move backwards to go to oxygen. Does that make a little bit more sense? Okay, awesome. All right, do you understand why we're getting the 2 and the 1 from? For the coefficients. Do you understand where we get that from, Alex? Awesome. Okay, so let's try another one. All right, how many moles of O2? So where am I going to put our X? Because it's asking about the moles of O2, that's where I'm going to put my X. And I'm going to put the unit moles there. Try to get in the habit of using moles, because starting next week, it's going to start asking for grams and liters and stuff like that. So how many moles of O2 are produced when 3 moles of KNO3? So here's my KNO3, and we have 3 moles here. That's my starting number. Very good, Alex, under the O2. And then we put the 3 moles under KNO3 because that's our starting point. We're going from here to here. In order to use the coefficients, this is important, you're going from moles to moles. Those are the units you need to have everything in. It's already in moles, so we don't have to worry about that. Be careful of this next week. Next week, we start using grams and stuff like that. In order to go from moles of one thing to moles of another, we're going to use coefficients. I know. All right. So our starting point is this 3 moles of KNO3. That's the number that was actually in the question. That's the number that's going to go over 1. No, I think we're on question 3, I want to say, on our worksheet. We have moles of KNO3 on the top. That means I want to put moles of KNO3 on the bottom of the next one so they can cancel out. Andrea, I think it's the first page of the new worksheet. The new one that just got put out online today or yesterday. And I think it's question 3 of that. Did you find it? Awesome. Okay, so Aiden, stop playing with your Rubik's Cube and actually pay attention. Thank you. just like in school. All right. 3 moles of KNO3 is our starting point. So we were going to put it on the bottom here so it can cancel out. Because we're going from moles of one thing to moles of another, we're changing compounds. We have to use the coefficients for that. 2 is the coefficient in front of KNO3. So that's what I'm going to put on the bottom. So that way that can cancel out. On the top, I'm going to go where I want to go to. All right, so since I'm looking for moles of O2 on the top, I want to use the coefficient for O2, which is the coefficient of 1. So it's going to be 3 times 1 divided by 2. That gives us 1.5 moles. Notice the KNO3 cancel out. The only thing we have left over is moles of O2. All right. Noah, did you find the worksheet we're working on? It's in Google Classroom. Okay. So for number 4, it says how many moles of KNO2? So I'm going to look for KNO2 in the chemical equation. Right. Because it says moles, I'm going to write the unit moles here. We are starting with, it says R produced when 3 moles of KNO3 react. So I'm going to put 3 moles underneath KNO3 because that's my starting point. Notice we're changing compounds. We're going from KNO3 to KNO2. Anytime you change compounds, you have to use the coefficient. So when we go from here to here, we have to use the coefficients. In order to use the coefficients, you have to have it in the unit moles. I'm making a point of saying that now because next week we start throwing in grams and liters. All right, so our starting point is this 3 moles over here. So 3 moles of KNO3 go over 1. That's the number I'm trying to convert. That's my starting point. I have moles of KNO3 on the top. That means I want to put moles of KNO3 on the bottom of the next one. Because whatever's on top needs to be put on bottom. Where we're going from is on the bottom, where we're going to will be on the top. So since we're looking at KNO3, we want the coefficient for that, which is 2. So the coefficient is 2, and that's what we're coming from. Where we're going to is the KNO2 over here. So we're going to put moles of KNO2 with the coefficient of 2 on the top, because that's the number in front of it in the equation. So 3 times 2 divided by 2. And I just realized I have the wrong answer here. Should be 3 here. 3 moles of KNO2. The moles of KNO3 cancel out. Noah, do you have a thumbs up on that process? Awesome. Aiden left. Alex, are you doing okay? I was confused by 1.5 at first. Yeah, I messed up. I just realized that as I was doing it. That's why you don't do things in the head. That's why you actually write things out. All right. How are we feeling with this process? Do you want one more, or do you think you're good? Maybe one more? I'm still confused on the stuff from the packet. Okay, so let me come back to the packet. Let's finish this recording first, okay? I think so too. Okay, so is it okay if I stop with this for now, and then I can just stop the recording and we can record something else? All right, so I'm going to stop this.